So hello students, welcome back. Welcome back to the new video. Today, in the previous video, we have discussed some topics about the algebraic expression. Today we'll discuss about the algebraic expressions in more details. Okay. So under this algebraic expression, we have discussed about the constant and variables in the last video. And today, if a constants and variables are being combined, okay, if the constants and variables are being combined, then we say this is an algebraic expression. So the constant and variable may be either combined by positive, negative multiplications and divisions. Okay, it may be either combined the constant if the constant variable is combined by positive addition, subtraction, multiplications and division. Then we consider them to be the Then we consider them to be the algebraic expressions. Okay, now you see, this is an algebraic expression? Yes, this is an algebraic expression. 2x is an algebraic expression. 3y is an algebraic expression. 7x is an algebraic expression. Am I right? Why? Because the numbers have been combined by the multiplication sign. Numbers have been combined by the multiplication sign. So, and numbers again it being combined by the 2. This is also an algebraic expression. This is also an algebraic expression. This is also an algebraic expression. Okay, so this is what the algebraic expression said. Algebraic expression is the combinations of variables and the constant numbers. Okay, either by the signs of positive, negative, multiplications and divisions. Okay, now, based on combinations of the algebraic expression, we have been subdivided algebraic expression into different types based on the term. Okay, now let's talk about the term. You see, what is term? Let's talk about the term. Based on the term, we algebraic expressions are being divided into different types of algebraic. We have been divided based on the term. If the term is what? The part of an algebraic expressions, okay, the terms are mostly separated. The part of an algebraic expression, which have been separated, okay, which are separated by positive, by plus and or plus or negative following. Okay, the term is what? Between the two numbers. Okay, between the two numbers, if they have been separated by either positive or negative sign, positive or additions or subtraction sign, then only we consider to be the terms. Okay, it may be a single terms, it may be a double terms, it may be a triple terms. Okay, now we see if this is a 2x, then we say this is a single term. That means one term. But if I say 2x plus y, then here's our term is double term. That means two term. If I say 2x plus 3y plus minus 7, then you say three terms. Only three terms. Okay, so this term is what? If the term between the two numbers, between variables and the constants, or the variables and the constant, if they have been separated by the positive, that is additions and subtraction, that means you can consider to be the two terms, three terms, or many terms. Okay, so mostly the terms are being separated by whom? By the sign called positive and negative sign. By the sign called plus and minus, that is addition and subtraction. Here you see y. This y is also a single term. Okay, this x is also a single term. This 3 is also a single term. All these numbers are single term. But when you talk about two term, what is it? Y plus x, x minus 7, y minus 2. Okay, these are all what? Double term. Why? Between these variables, they have been separated by the positive sign. Between these two numbers, they have been separated by the negative sign. Between these two numbers, they have been separated by the negative sign. Right? So that is what we call as a double term. That means two term. Okay. Now if the terms have been, let's say, 2x plus y plus minus 3, then this is called a 1, 2, 3. We have three terms. Okay, so mostly the terms have been separated. The terms have been separated by the positive, that is by the plus and minus. Okay, so based on this term, our algebraic expressions have been subdivided. If the algebraic expressions, if we have only one term, we call those expressions as a monomial. Mono means one, mial means term. Mono means one, mial means term. Having only one term. Having only one term. Okay, having only one term. If it is a binomials, binomial means what? It is a two term. Bi means two, mial means term. Having two terms. Okay, that means x plus y. X plus y. Two terms. Because it is separated by the plus sign. Binomial. Trinomials. Okay, trinomial means what? It is separated by the three term. Having three term. It is separated. Having three term. It is separated either by plus or minus. Okay, so having three terms. Example like binomial, when you talk about a binomial, that is what? 2x plus 3. So this is your binomial. Two terms is yours. Okay, here 3y is a binomial, monomial. Why? Because it is separated. There is no separation. 3 into y. We cannot consider if there is 3 into y. That means there is single terms. Okay, so when you talk about this one, 3 terms is what? 2x minus y plus z. It isn't separated by the home. Plus and minus. Okay, so this is what we call. We have three terms here. That is what we call as a trinomial. Binomial is what? Having only one term. Binomial means what? Having two terms. Trinomial means what? Having three terms is what we call as a trinomial algebraic expressions. Clear about this one? Now we see. Let's talk about the next topic. That is what we call as a factors. Okay, factors means what? Laterally it is a multiples. Okay, laterally we call this as a multiples. Okay, when two or m numbers or laterals are multiplied each others, okay, is what we call as a factors. What is that? Factors. You know the factors of 1. Factor means what? If we talk about the factors of 25 is what? We know that 1 into 5 into 5. These are the factors. Okay, what is the factors? 1 into 5 into 5 is the factors. Okay, when you talk about 10, what is the factors? 1 into 2 into 5 is the factors, right? So these are the factors. So what is the factors? Factors are the numbers when two or more numbers and literals. Literal means variables multiply itself. If you talk about 2x, what is the factor of 2x? That will be what? 2 into x. That will be what? 2x means what? 2 into x. Okay. 3x squared means what? 3 into x into x. That is what we call a factor. The factor of 3x squared is what? 3x. 3 into x into x. Okay. Next, when you talk about the factors, is what we call the multiply. This is a numbers and this x is a literal or variable where they multiply itself. Okay. So all they are multiplying itself. That is what we call as a factors. Okay, that is what we call as a factors. Okay, so you see, next you have a coefficients. Okay, a coefficient is a numbers, a numerical numbers multiplying to the variables. What is it? Coefficient is what? It's a numerical numbers that is multiplying to the coefficient is what? Coefficients is what? It's a numerical numbers that multiply to the variables. Okay, that means example you see 2x. This 2 is a numerical numbers. This 2 is a numerical numbers. This 2 is a numerical number, and this x is a variables. Okay, so if I talk about this coefficient as I define you this one, what is a coefficient? Coefficient is a numerical numbers. It's a numerical numbers. Okay, which multiply to the variable. Which multiply to the variable is what we call as a coefficient. So here you see, this 2 is a numerical numbers. It is multiplying to x. That means this 2 is what we call as a coefficient. Okay, this 2 is what we call as a coefficient. Okay, so when you talk about next, 7x, 7y. Okay, so how do we which one is a coefficient? This 7 is a coefficient of whom? X. 3 x square. What is the coefficient? 3 is the coefficient of x square. 3 is the coefficient of x square. Okay. So this is what we talk about the coefficients. Okay. Now let's talk about the next term. Next is what? What are the like terms and unlike term? This is very much important for your higher classes. If you don't know the like terms and unlike term, you cannot do the addition, you cannot do the subtraction. So you need to be very clear about like terms and unlike terms. What is it? Like terms and unlike terms. Okay, like terms are those terms. If those terms where you will get the same variables. Okay, like terms are what? They will have the same variables. Okay, same variables and same degrees. Same degree. That means what? You talk about this one. Okay, 2x and 7x. This is what we call as a like terms. They will have the same variables. That means x and x are same variable. X and x are what? Same variable. X is also a variable. 7x is also another x is also a variable. Okay, they will have a same variable, but again they will also have a same degree. Is what we call as a like term. Does it matter about the numerical values? Does it matter about the magnitudes? Okay, that is what we call numerical value, or we also call as a magnitude. Whether it is, you see, 7x, 7y and 10y, that is what we call as a like term. Why? Because y and y here, their powers are also same here. That is what we call as a like term. 20x squared and 3x squared. You see, this is also a like term. Why? This is x, this is x, same variable. 2 squares, squares. This is same power. Then they are called as a like term. But when you talk about this one, 2, if you talk about this and if you try to compare these two, they are not a like term. Why? Because though they have the same variable, but their degrees are not same. What is it? Their degrees are not same. So to be a like variable, what are the conditions needed? To be a like variable, the condition needed is what? It should have a same variable and it should have a same sign. It should have a same variables and it should have a same degree. Okay, it should have a same variables and same degrees. Clear about this one? Next, you see, unlike term, what is it? Unlike term is what? They don't have they may have a same variable. Doesn't matter. They may have a same variable also. They may not have a same variable also. Okay, and their degree may not be same. Okay, so like term, this condition is very much important. For like term, you need the example of unlike term is what? 2x and 7xy. Okay, you see, the variables are different out here. That is what we call as the unlike term. 2x and 2x squared. Okay, you see the variables are same, but their powers are different. That is what we call as unlike term. Okay, so unlike terms are what? If the terms have a same degrees, if the term have a same degrees, okay, if the sum have a same degree and same variable is what we call as a like term. If the sum have a different degrees, different variables, okay, that is what we call as a unlike term. Okay, so unlike term, what is the condition? Another important, you see, unlike term can only do the addition. Okay, like terms can go for addition. You can add them. Okay, you can subtract them. You can multiply them. If they are multiplication can be done. Okay, next is what? Divisions also we can do. Okay, if they are like terms, we can do the addition, we can do the subtraction, we can do the multiplication and divisions. Okay, but if they are unlike term, that means we can only do divisions and multiplication. Division and multiplications. Divisions and multiplication. We can only do the divisions and multiplication in terms of unlike term. But in terms of like term, we can do the addition, subtraction, multiplication and division. That means what? 2x, in terms of this one, you see, 2x plus 5x, we can add them. That means it becomes 7x. Okay, but here you see, if you talk about this is unlike term, 2x minus 3y, we cannot subtract them. because they are unlike term. This is x and x. So in this term we can only do the divisions and multiplication, but in like term we can do the addition, subtraction, multiplication and divisions. Okay, we can do all the methods, all the operations out here in the like term, but we can only do the divisions and multiplications. Okay, so this is all about the basic of the algebraic expressions. Okay, so we'll try to understand some questions from the 6.2. Okay, so 6.2 question you see, I'll just give some questions. Okay, here it's on the board. Do you think this one, x squares, number one, x squares plus y squares, it is the binomials, the trinomials or monomials? What is it? Okay, what is it? Is a binomial or trinomials or monomials? Obviously it is a binomial. Obviously it is a binomials. Okay, it is a binomials, right? Why? Because we have two terms here. 1, 2. Okay, next, if we talk about number 8. Question number 1, number 8. X squares plus 2xy plus y squares is what? It is called, it will be what? Binomials or trinomials? It will be a 1, 2, 3. 3 term we have, it will be considered as a trinomial. Trinomials. Know about this one? We'll consider as a trinomials. Okay, now when you talk about number 5. Number 5, what is it? 4x cubed. I don't know, 4x cubed. Yes. So it is a what? Only one term is here. That is what we call as a monomial. This is what we call as a monomial. Now when you talk about 2x squares. 2x squares minus 7 is what? 2x squared minus 7 will be binomials or trinomial. We have only two terms here. 1 and 2. Terms are separated by the additions and subtractions. So these are two terms, so this is what we call as a binomial. This is what we call as a binomials. Clear about this one? This is what we call as a binomials. So in this way you try to solve the question number 1. Okay, what is it? Exercise 6.2, question number 1. And now let's try to write down the question number 2. Let's try to solve the question number 2. So here, question number 2 said write the coefficients of x in the following. Number 1. Number 1, what is it? 4ax. Okay, you have to write the coefficients of x. Now you see, coefficients of x is what? Coefficients of x is what? You see, except x, you try to close it the x, the remaining numbers are coefficients. What is the remaining number? 4a is the coefficients of whom? X. Okay, similarly number 2. Minus 10xyz, so coefficients of x is what? Coefficients of x is what? Close the x, close it the x, the remaining numbers are coefficient. What is the remaining number? Minus 10 and yz are coefficients of x. Okay, they are the partners of that x. We can say partner. Okay, we can say partners. Okay, so partners of x is what? Minus 10 yz. Okay, similarly if we talk about 24xyz, number 3. 24x y square z. So coefficients of x is how much? 24 y square z squares. Clear about this one? 24x square y square z squares. So now number 5. Number 5. What is it? Number 5? Your number 5 is minus 5 by 2. Minus 5 by 2 x y z square. So what is the coefficient? That is minus 5 by 2 y z square is the coefficients of x. Only close to f x and remaining numbers are coefficients of x. Okay, so in this way you try to solve it. What is it? Question number 2. Okay. Okay, let's go to question number 3. Okay, write the numerical coefficient of each of the following terms, of the following algebraic expressions. Okay, so I will just do only two questions. Okay, two questions, that is number 1 and number 2. Remaining you try to do it by yourself. It is very easy. Okay, number 1, question number 3. Number 1, write the numerical coefficients of each of the following terms. Minus 7 x cubed y plus 5xy minus 2. Okay, so numerical coefficients of x cubed is what? Numerical coefficients of x cubed is, we don't have nothing in front of x. Nothing is there in front of x cubed, right? Nothing is there in front of the x. That means we will consider there is a 1. Okay, always remember there is a 1 here. If you don't see any numbers out there, remember that is a 1. Okay, we don't write this as a 1, right? Similarly, numerical coefficients of what is it? Numerical coefficients of what? Numerical coefficients of x squares and y. Only numerical means numbers. That is what? You see x squares and y, what is written here? Minus 7. Numerical coefficients of what? Numerical coefficients of what is it? xy. What is it? Is only 5. Okay, so in this way, the numbers, that is 2, is a constant number. The number. So next is what? Constant number. Constant number is what? Constant number is, that is also numerical coefficient, that is minus 2. Okay, so these are some numerical coefficient. In front of x we have 1. In front of x squared y we have minus 7. In front of xy we have 5. In front of 2, that is a constant number. This is also a numerical coefficients. Okay. Similarly, number 2. Okay. Similarly, number 2. So what is given? Okay. So numerical like I'm writing numerical coefficients of each term. Each terms are, okay, what is it? Number 1, that is what? In front of a, what is written? This is 2 is written, so this is number 1 minus 2. Then in front of a, b square, what is written? Numbers, that is what we call as a numerical values, that is 7. In front of a, b, what is written? Minus 6 and 8. So these are the numerical coefficients of number 2, that is Roman number 2. Okay, similarly, one more question. So similarly here is the numerical coefficients of what? Numerical coefficients of question number 3. Coefficients of each terms are, what is it? Minus 3 by 2. Okay, in front of this we have minus 3 by 2. Then x, y, z we have 5 by 3. And then zx we have minus 7 by 4. These are the numerical coefficients of the following terms. Okay, so this is all about the question number 3. Okay, so question number 4, we'll try to do question number 4. Okay, these are some questions. Okay, numerical values of coefficients of y in minus 5y is what? Minus 5 is your coefficients. Okay, so here's y in 7y is what? Except y, remove y, what is the remaining? These are your coefficients of 7. Now coefficients of x cube, you see, x cube plus 1. Multiplying, we said, coefficient is what? Is a multiplying values of whom? The multiplying value to whom? Are variable, not additions. Okay, we are not talking about additions. Coefficient is multiplying. So here you see, this 1 plus 1 will not be included. What is remaining here? In front of x cube, what is here? We know that there is 1. So this is what? Coefficients of x cube is what? 1. This is your answers. Okay, so this is your answers for the entire what is it, Roman numbers, question number 4. Okay, so we have 8 more questions that we will do in the next video lectures. Okay, so we'll try to solve out the remaining questions that are left.